Okay, I'm going to go through the answers to the questions on the sheet. Hopefully you've done this by yourself. First section, just reactivity in general. What do all metals do when they react? They all lose electrons. Magnesium's in group 2, which means it will lose 2 electrons. Sodium's in group 1, it will lose 1 electron. They react with non-metals and they form ionic compounds. Metals don't react with each other. They want to lose an electron. They need to find something else that will gain electrons. So they always react with non-metals, and when they do, they form ionic compounds. Because you've got ionic compounds, the particles you have got are ions. That's what I mean by particles. Okay, you've got positive ions and you have got negative ions in an ionic compound. The next bit, extraction of metals. What metals are found as pure metals in the Earth's crust? So these are the two most unreactive metals in our series, silver and gold. Because they don't react, they're found as pure metals. The next question I ask you, why are they pure metals? Because they're unreactive. What is an ore? So actually I didn't cover this in my revision video, but it's in your... What is an ore? So I didn't cover this in my revision video, but it is in your notes. An ore is a rock that contains metal. Okay, but that's not the end of the definition. You have to be able to extract, to take the metal out for profit. So what I mean by that is if it's going to cost you £1,000 to get some iron out of a rock and you can only sell that iron for £50, you are not making a profit. That rock, even though it contains metal, does not count as an ore. So basically what it means is you need to have very good quality metal or a lot of the metal in order to call a rock that contains metal an ore. So that word profit needs to be in your definition. How are you going to extract a metal from an ore? Okay, the two main methods we have are going to be electrolysis and reduction with carbon. But if you mentioned either of the biological methods, so phytomining or bioleaching, that is also okay. Suggest why it's important that we can extract pure copper from copper ores. Okay, pure copper just has loads and loads of uses. So we use copper used in... It's used in pipes, so water pipes. It's used in electrical wires. So pure copper itself has loads and loads of uses, important uses, whereas the compounds of copper can't be used for those things. So it's really important that we can get pure copper. How are we going to do this? All right, I'll go through the different methods of extraction. First one, reduction with carbon. Using your activity series, list all the metals. So every metal below carbon can be extracted. So I'm going to have iron, zinc, copper. I think I might have lead also on your reactivity series. If I do, you can include that. I'm not going to include silver and gold. I don't need to extract them. They're unreactive. They're going to be found as pure metals. So any of those answers are acceptable. Complete the following word equation. We've done this over and over again. I'm swapping iron and carbon because carbon is more reactive. And when I swap them around, I don't actually get carbon oxide. I get carbon dioxide and I get iron by itself. When I swap these two around, I get zinc plus carbon dioxide. It doesn't matter which order you write the carbon dioxide in the metal. It can be either order. They're both fine. What is reduction? Next page. Reduction is just the removal of oxygen. Now we have seen another definition for reduction, oil rig. Reduction is gain of electrons. But in this case, we're talking about the removal of oxygen, although either definition will get you marks. In the reactions in question 2, identify what is being reduced. Okay, so on the left, I've got iron oxide. So iron has oxygen. On the right, it does not have oxygen. Zinc oxide. Zinc has oxygen on the left. Zinc doesn't have oxygen on the right. So what's being reduced? In the first equation, iron oxide was being reduced. In the second equation, zinc oxide was being reduced. Explain why heating element will not produce pure aluminium. Aluminium is more reactive than carbon. If it's more reactive, it's not going to work. So more reactive than carbon. Move on to electrolysis. We've seen this question so many times. What state must ionic compounds be in to carry out? They must be molten or aqueous. Okay, they have to be in liquid form. To get them in liquid form, melt them, dissolve them in water. A student tried to electrolyze solid. It didn't work. Why did it not work? In solid NaCl, the ions can't move. And you need to use that word ions in order to get your marks. What are the products when molten? So if it's molten, you've got no water there, which means I've only got sodium and chlorine. When I split it up, I'm going to get sodium and I'm going to get chlorine. Okay, if it's molten, there's no water. They're your only two products. A student used aqueous sodium chloride and saw bubbles at the cathode instead of sodium forming. Explain why the students saw bubbles. So if it is aqueous, it means I've also got water in there, which means I've got hydrogen, H plus, and I've got OH minus. They're telling me I'm seeing bubbles at the cathode. I'm just going to draw myself a little diagram. There's my two electrodes. This is my anode, and this is my cathode. So they're asking me why I'm seeing bubbles at the negative electrode. To my negative electrodes, the positive ions are going to go. So H plus and Na plus, they're both going to go to the cathode. The least reactive forms, so hydrogen is going to form. So all you need to write is hydrogen forms. Hydrogen is a gas. That's why you're seeing bubbles. Hydrogen is a gas. Describe what products are formed during the electrolysis of potassium bromide solution and explain why universal indicator turns blue. So it's solution, so that again tells me I've got water present. If it's aqueous and the metal is not copper, then I'm going to get hydrogen formed. On my other product, I've got a halogen. The other product is going to be bromine. Hydrogen and bromine are going to be my products. Why does the universal indicator turn blue? Okay, if the universal indicator is turning blue, it tells you that you have got an alkali. The ion of an alkali, the ion that makes it turn blue is OH minus. Okay, universal indicator turns blue because OH minus is present. Where am I getting this OH minus? We said it was in solution. If it's in solution, you've got H plus and you've got OH minus. That H plus is converted to hydrogen, but the OH minus remains. Once you throw in some universal indicator, it will turn blue because that OH minus is present. Okay. Anytime you're asked about universal indicator turning blue, it's because you've got OH minus. If you were asked why did it turn red, it's because you've got H plus. Last questions. Biological methods of extraction, phyto mining, and bioleaching. An advantage and disadvantage of phyto extraction. An advantage, you can use low grade ores. A disadvantage of phyto mining is that it is slow. An advantage and disadvantage of bioleaching, you could write exactly the same thing and it's fine. I'm going to write less mining as an advantage, but you can also write use of low grade ores, and I'm also going to write that it's slow. Okay, they're both slow. It's an advantage for both. Hopefully you found those questions okay. If you didn't, that's what Teams is for. So message me in Teams with any problems that you had, any questions that you still don't understand, and I will do my best to answer them.